evening, everyone. Welcome to the third plenary session of the 7th International Research Conference on Humanities and Social Sciences, organized by the University of Sri Jayawardhanapura, Sri Lanka. Our speaker this evening is Professor T. Daniel Seeley of the Department of English Language and Literature of the Eastern Michigan University, USA. I feel really honored and privileged to introduce Professor T. Daniel Seeley to this diverse audience. Daniel T. Seeley earned his PhD in linguistics from the University of Massachusetts, Amherst in 1988. He has been a professor in linguistics at EMU over several decades. His research and teaching is mainly focused on biolinguistic theory, specifically on language as an organ of the human brain. His main research interests include theoretical syntax, semantics, and psycholinguistics. Professor Seeley has published his research in many renowned journals in the field of linguistics, including Linguistic Inquiry, Syntax, and Linguistic Review. And also, he has authored a number of books with his collaborator, Samuel D. Epstein of the University of Michigan, and Further, he is a member of a research team famously known as the Team IRCHSS in the field, which also includes Samuel D. Epstein and Kitahara of Keio University, Japan. Their work resulting from this collaboration has been published by some leading publishers in the world, such as the Cambridge University Press, Oxford University Press, and John Benjamin's. Some of the outstanding publications that Professor Seeley has co-authored include Derivations in Minimalism, The Anatomy of Chomsky's Biolinguistic Minimalism, Handbook of Minimalist Linguistics, Economy of Derivation and Representation, and Explorations in Maximizing Syntactic Minimization. The latest publication of the IRCHSS team, A Minimalist Theory of Simplest Emerge, Routledge Leading Linguistic Series, is expected very soon. In summary, Professor T. Daniel Seeley is a leading researcher in biolinguistics, an approach to linguistics pioneered by Noam Chomsky, one of the leading thinkers of the 20th century. This evening, we feel honored to have Professor T. Daniel Seeley as an invited speaker of IRCHSS 2021. His topic this evening is Toward Explaining Language, the Minimalist Perspective. The plan of the session is that first, Professor Seeley will speak for 45 minutes, which will be followed by a 15-minute Q&A session. If you have any questions, feel free to send them to the chat box. Now, I cordially invite Professor T. Daniel Seeley to deliver his plenary speech.
Okay, thank you. And I'm just going to share the screen and get this PowerPoint up, and we should be ready. Okay. All right. Okay. All right, so thank you very much for that introduction, and many thanks to the organizers, particularly to Dr. Sujiwa Hetiarachi and the university there for the invitation. I really appreciate it. These are difficult times, and I really wanted to be there in person, but I'm happy to participate in this event in any capacity, even if it's through technology. So I'd first like to thank my co-authors and collaborators over the years, particularly Hisa Kitahara and the late Samuel David Epstein. This talk is deeply influenced, every word, by co-research and co-authorship with those two, and then extensive discussion and interaction with these colleagues. I want to acknowledge and thank them. The broad goal of this talk is to review key aspects and significant historical developments in what's called the generative enterprise, the work of Noam Chomsky beginning in the mid-20th century and continuing to this day. I want to clarify certain leading ideas of this program working our way toward a general understanding of the minimalist program. That's a title for recent developments in the more general generative enterprise. I'll avoid technical detail. I want to present the broad strokes of the research program, some history, some consistent themes that run through the work, some developments in current thinking and prospects for the future. For concreteness, we will focus in a non-technical way on two central properties of language, phrase structure and displacement. And I want to do this in order to illustrate in somewhat more concrete terms how the theory has developed over time, and to illustrate what can be called explanation by simplification, an important component of the minimalist program. And we'll see what all that means as we go along. Let's start from the very beginning. Generative grammar represents a theory of language. The research attempts to construct that theory of language and seeks to explain certain properties of language. So to engage in this activity, we need to know what the object of inquiry is. A foundational, fundamental question is, what is language? Now, I'm in an English department and walking through the hallways and walking around the university through different departments, people are talking about language all the time. But what I've learned is that the term language means very different things, sometimes radically so, depending on the subfield that you're in. In an English department, one perspective on language that's common is based on language use. So how is language used for effective communication, say, or what are the proper forms for speaking and writing? Another perspective on language is that it's out there, removed from human bodies. So we might say, for example, that there's English in this book, or I might overhear a group of people talking and I might say, I hear language. So it's out there on the page or in space. And there are other characterizations. The generative enterprise starts from a different perspective, and it might seem a little bit counterintuitive initially. First, we separate the object from the use of the object. The skeletal system is not ballet. Rather, the skeletal system is used for ballet, and language is not communication. Rather, it's used for communication. Likewise, with the visual system, the vision scientist is not constructing a theory of what you look at, that or when or why you look at paintings rather than the ocean. Now, I use language for all sorts of things. Primarily, I think we use it for thinking and internal activity, but I can also use it for communication. I can try to persuade you or compliment you, countless other things. But we can still ask, what is the it that I'm using for those things? What is the object language that I'm putting to use? So we separate some element, some system X from the use of that system. And note further that a core property of language is not out there. So we said this was language a second ago, but the linguist is not studying ink marks on a piece of page. And if I hear people talking, what I'm literally getting are perturbations of molecules in space. That's what's striking my eardrum. So those, the page and language sort of in space, are externalizations of some deeper notion of language, which is somewhere else. From its inception, the generative enterprise has adopted a biolinguistic perspective. On this view, language is a cognitive capacity of the human brain. It's a part of your body. It's inside the individual, and the term I language for internal and individual and intentional is sometimes used to distinguish this perspective from other perspectives on language. So what is language? It's this hypothesized capacity. Where is it? It's in the human brain, language as a biological object. Now, I want to think about this in a little bit more detail. Let me start with what I think everyone would agree with. You know language L, whatever that language happens to be. Let's use English for purposes of illustration here. We can illustrate exactly the same points with whatever language you choose. You are in a knowledge state. You know English, and that knowledge state manifests itself in many clear ways. You can make sophisticated judgments about grammaticality, about well-formedness, about ambiguity, and you can make these judgments about expressions that you've never encountered before. It's a highly sophisticated knowledge state. It's not explicitly taught to you, and you can't just extract it from the environment. Well, let me give you some examples. Consider this sentence, perfectly fine yes, no question. Will the man who can whistle win a prize? You would agree that's fine. The answer might be, yep, the man who can whistle will win a prize. But look at this one. Can the man who whistle will win a prize? We know immediately that there's something ill-formed about that. You know that when you know English. You know that this simple sentence, horses are to walk, horses are to walk, that simple sentence is ambiguous. It can mean horses are themselves to walk. Horses are to walk across the yard at dawn, for example. Or it can mean we are to walk horses. Something like the purpose of horses is to walk them. Horses are to walk. You know that when you know the language. You know that I sprinkled water on the plants is well-formed, and I sprinkled the plants with water is also well-formed, and they mean essentially the same thing. But switch out the verb, and I get, I drenched the plants with water. That's fine. But the corresponding sentence, I drenched water on the plants, is not. You know that when you know the language, and nobody ever explicitly taught you that. You also know, and it's a curious fact, that this sentence means what it means. Which man do you think that John wants to visit? You know that the interrogative expression, which man, is interpreted up here at the beginning of the sentence, but it means down here. It's understood as the direct object of that transitive verb way far away from it. You know that. This is what's called displacement, and we'll talk about this a little bit later as we go along. So you have massive knowledge of language. It's in your head. It's not in your thumb or in your living room. It persists over time. You don't relearn the language every morning. It exists when you're not using it. You still have that capacity, just like you have the capacity to see, even if your eyes are closed, or the capacity to swim, even when you're sleeping, even when you're not using it. That knowledge is the focus of the biolinguistic perspective. And a central question is, what does your knowledge of language, what does your knowledge of English in this case, consist of? What does it look like? From the biolinguistic perspective, language is this cognitive capacity of humans, and the object of inquiry is that internal capacity. And one research goal is to attempt to construct a theory of it. Things are very interesting, though, because we have a fundamental question right from the beginning, and I would phrase it this way. How can we have one language and multiple languages at the same time? And this is what I mean. Consider this a human baby, and consider this a puppy. Now, I can give those both linguistic input. I can talk to them, and something very different is going to happen. The human is eventually going to talk back to me. The human is going to acquire, grow knowledge of language, but not the puppy. I think we would all agree that there's something very different about these two. The human has a human language capacity. And it's uniform for the species. Take any human baby, put that baby into any linguistic environment, and the baby will grow the ambient language. There's a massive naturalistic experiment taking place on the planet that shows this. So there's one human brain and there's one human language capacity. And one of the things we want to do is characterize that initial state. What do you have in your head that the puppy doesn't? But we also have the following. We need to characterize states attained, because upon interaction with the environment, if I give the baby input, they're going to acquire what we call a particular language, a particular I language, French or English or whatever it happens to be. So what factors are involved in the growth of language from this initial faculty that you have to particular states of it? How is that possible? That's a central research question. So the biolinguistic perspective assumes that there's this species-specific, innate, uniform language capacity. It reaches a state called an I language. It manifests itself in this massive knowledge that you possess. Now, clearly, there's interaction with the environment to trigger its growth. That's true in that if there's no French in, there's no French out. It's never happened that a baby has gotten exclusively French input, but speaks only German. Language is in part grown, though, in large part grown, not learned on this view. We don't explicitly teach kids the kinds of things we talked about earlier, but we need to be careful. Because when we say the child gets linguistic input, we might say they get language. That's not really the case. The child is not getting nouns and verbs and meanings because nouns and verbs and meanings are not going through space. What's literally going through space are perturbations of molecules, and the baby gets vibration at the eardrum or retinal images at the eye if it's sign language. What the child grows is largely done on the inside. This is called the poverty of the stimulus argument. I don't give an acorn tree for the acorn to grow into a tree. I give it water and earth, and I don't give the baby language. That is, what the baby acquires is very different from what goes in. It gets acoustic disturbances and retinal images, and it somehow is able to acquire a knowledge state. So there's a condition on any theory of I language that we construct. How do we get one language in multiple languages? And that we might call the condition of learnability. So those are some notes on the biolinguistic perspective. Again, it's not a theory of language use. We're not constructing a theory about why you choose or why you choose to talk about what you talk about or when you talk about it, why you talk about politics rather than archery, any more than the vision scientist is constructing a theory about why or when you look at oceans rather than mountains. We're constructing a theory of the cognitive capacity. So there's a distinction made between possession of knowledge and the use of that knowledge. All right, so the next question we might ask is, how are we going to study it? And I mean a number of things by this. Linguistics is the scientific study of language, so we're going to use the methods of science, and that's already a big step. One thing that means is we're going to attempt to be objective, so there's no prescriptivism. Your emotions or your feelings about certain knowledges, certain languages or constructions or dialects are left outside the laboratory. It's not a theory about how language should be, but how it is. So the systematic knowledge state that we find in individuals. We're also not saying anything, at least not directly, about what makes good writing or a good narrative or a good metaphor. Again, the focus is on the capacity. Now, another thing is we want to make precise formal hypotheses that are testable against data. So there's a good deal of mathematical formula. This, for example, is a recent definition of a fundamental operation of the language called merge. We're going to talk about merge a little bit later. And the only reason I want to show it is that the statements and principles and definitions are precise, often using formal mathematical devices like set theory in order that they be best evaluated. And then, like science in general, we don't stop at description. It's important that we have careful description, but ultimately we want to take steps toward explanation, asking and attempting to answer questions about why the language has the properties that it does. Why does the language have the kind of phrase structure that it does? Why does language have displacement? And many other such questions. Richard Feynman states it this way: in the further development of science, we want more than just a law. We want more than just a formula. First, we have an observation, then we have numbers, then we have a law which summarizes all the numbers. But the real glory of science is that we find a way of thinking such that the law is evident. So another point to make about how we're studying it involves the inherent abstraction of science. And what I mean by this is the following. We want to study this cognitive capacity of humans, and it's in the brain. But I don't have direct access to that. I can't just pop open your head and see that language capacity. I don't see relative clauses or agreement. But one idea is if it's in the brain, then study the brain. Well, if I want to learn something about language, I'm going to a linguist, not to a neurologist. With the brain, I can get the firing of a neuron or blood flow, but at least at this point, I'm not going to find relative clauses or case assignment or agreement patterns. So how are we going to study the language in this sense? Well, a great deal of important theory building has been done not by looking at the brain, but by looking at certain kinds of behavior. So by looking at the consequences of the language faculty. So consider the judgments we made earlier. Those we said are manifestations of the knowledge state, and I can use them to probe certain properties of language. Just like in vision scientist, I can use your reaction to a Necker cube to figure out certain information about your knowledge of perspective, say. So consider the example that we looked at earlier. The yes/no question, will the man who can whistle win a prize? Can the man who will win a prize? You know that there's a distinction between those. So I look at those judgments and I say, what must your knowledge state be like in order to account for that distinction? And I want my rule systems to shed some light on this. Again, I'm not studying the behavior itself. That's not the object of inquiry. The object of inquiry is language, but I can use that behavior, your reactions, your introspective judgments to gain certain insights. And this kind of introspective data has proved quite useful in linguistics. It's used throughout linguistics and in other domains as well, like the vision sciences. But ultimately, in the generative enterprise, any source of data that might be relevant will be used. Corpus studies or acquisition studies or psycholinguistic experiments. But the model that I build is going to be abstract. As in science generally, we see abstraction of this kind. The cardiologist studies the human heart, but the human heart is an abstraction. I might look at a particular heart. I might look at Mary's heart to learn something about it, but Mary's heart is not the heart that is the object of inquiry of cardiology. Likewise with science in general. Von Humboldt stated it this way: the demand of science in all its manifold appearances is always the recognition of the invisible in the visible. The invisible, the abstract scientific postulates that we wind up with. So I'm going to build a theory of that possession of knowledge, and then I want to engage with my colleagues in different departments across the university and ask a series of further questions. How does that language capacity interact with other cognitive biological systems, for example? What are its physiological underpinnings? How does it grow in the individual? How did it evolve in the species? How does it change over time? And crucially, how is it put to use? But under the biolinguistic perspective, the central goal is a theory of the knowledge state itself. So the generative enterprise, stating it in terms of its absolute essence, it's the attempt to construct an explanatory theory of this notion of internal language, of language. Okay, so we're exploring what's referred to as the generative enterprise, and we will be making our way toward its recent incarnation, the minimalist program. There are two properties of language I want to discuss: phrase structure and displacement, and we'll use these to illustrate explanation by simplification. Let's turn next then to phrase structure. To set the stage, I want to address the problem of discrete infinity, recognized at the earliest point in the development of the theory. You have detailed knowledge of unencountered expressions. Your knowledge then can't just be a list of sentences that you've memorized. I can keep giving you new expressions. They're brand new. You're encountering them for the first time, so you couldn't have memorized them, and you still have detailed knowledge of them, like the cases we saw earlier and most of the examples of language that you hear or produce in the course of your day. I sometimes tell my students this is what plagiarism is all about. You have an infinite capacity, infinite creativity. You can keep creating new sentences, so many that there's enough to go around for everyone to have their own sentences, and there's no need to take anyone else's. But the brain is finite. The mechanisms of language are finite. So how can a finite apparatus have an infinite output? Chomsky refers to this as infinite use of finite means and considers it a core creative property of knowledge of syntax, recently referred to as the basic property. Each language yields an infinite array of hierarchically structured expressions which get interpreted for sound and meaning. Now, the solution in the earliest days of the generative enterprise was a set of recursive phrase structure rules. And to appreciate this, I want to spend just a little bit of time talking about phrase structure more generally, just enough to appreciate a number of important points. First, let me locate this in the larger context. Let me give you the big picture. Generative grammar separated out the lexicon. That's the mental dictionary. You know right now a finite number, something on the order of 50 or 60,000 basic words and word parts. These are the atomic elements out of larger things, out of which larger things are constructed. So I can draw elements out of the lexicon. I can draw two words like the and man, for example, and I can assemble them using some computational device in what we might call the workspace. So I put the and man together, and then I can reach into the lexicon and get sleeps a lot and put those together. And then in this computational space, I can put the man sleeps a lot together and get the structured object, the man sleeps a lot. Now that object that I've built with these computational devices is given over to interpretation, to the faculties associated with interpretation, the phonological component and the semantic component. And it will ultimately interface with external systems, external to the language itself, but still internal to the human body. So the sensory motor system and systems of thought. So the sensory motor system, the objects that I produce in the workspace are going to be given over, and they will be essentially a set of instructions about how to move my mouth to speak, how to move my hands to sign. And it's also going to be given over to the semantic component and ultimately to the conceptual intentional system, where I've got general inference and interpretation and planning and organization for action, informally speaking, thought. So that's the big picture. And we're going to be focused for a few minutes on this section right here. That's language in the narrow sense. And there are two computational devices that I want to focus on: phrase structure and displacement. And these will show us certain properties of language that will play a role in this idea of explanation and minimalism. Okay, so there's the big picture. Now, here's the next step. Sentences are not just made up of strings of words. So there's a sentence: the linguist visited that beautiful country. That's a sentence, S for sentence. It's not just a set of 6 words and that's all there is to it. That assumption gets us nowhere in accounting for your knowledge of language, for your capacity, the kinds of phenomenon that we looked at earlier. Rather, there's evidence that there's structure above the word level and below the sentence level. Massive, wide-ranging, diverse evidence for this structure for phrases. That is, for groups of words that go together to constitute a unit. So words can go together semantically. There's semantic evidence. They go together syntactically. There's grammatico-syntactic evidence, morphological and phonological. So we have evidence for phrases. The next question becomes, how do we represent them? And this is where Chomsky's phrase structure rules come into play. And I want to give you a basic idea of these phrase structure rules so we can see an important property called recursion that'll help us account for discrete infinity. So the basic idea of a phrase structure is this. Any category X consists of, it contains within it, other categories Y and Z. So we can understand that with a particular example, understand it a little bit better. The category S for sentence, a sentence consists of, it contains inside it the two things NP and VP, and that's like your old school days, a subject and a predicate. And then we can have another rule: a verb phrase consists of a verb plus a noun phrase. Now, these rules can be interpreted hierarchically. So reading them from top down, the first one says the category sentence contains within it, it consists of a noun phrase and a verb phrase. Reading the second one top down, the verb phrase consists of, it contains within it a verb and a noun phrase. And now I can insert lexical material. And now I have a structured object that we call a sentence. A structured object. So these two things go together to constitute a unit. There's all sorts of evidence for that. These elements go together to constitute a unit. And these elements go together. The verb plus that noun phrase go together to create a predicate. There are these structured objects. Now, the phrase structure rules give us this hierarchical structure. They give content to the notion these elements go together semantically and syntactically. They also give us linear order. The noun phrase, the linguist, comes before the verb phrase, likes the beautiful country. And there's a critical property of these, which is called recursion. And phrase structure rules are recursive, which means that they can apply to their own output. So I can apply the first rule and generate this object. Sentence consists of NP-VP. That's the output of the first rule, and that would be a structured representation for a simple sentence, like, for example, it's raining. And now I can apply the second rule and use the output of the first rule as input. So I'm going to apply the second rule. I'm going to use the object that I just built, put that inside the verb phrase. That's going to be an object. And now that can serve as input to the first rule. And I can get embedding. So I have it's raining, and then I can get the sentence Bill said it's raining. And I can keep doing that over and over and over. That's the recursive part. And I can get things like Bill said that Mary thinks that Tom suspected that it's raining. And that just is infinite use of finite means. With just a few words and with just two phrase structure rules, I can have a system that has an infinite output. So I have a solution to the problem of discrete infinity. So that was an important step in the development of the generative enterprise. And over the decades, initially, what developed were detailed phrase structure analyses of the languages of the world. So we saw the phrase structure rules of particular languages, like the phrase structure rules of French or Japanese or Zulu. We had construction-specific phrase structure rules, detailed, descriptively rich analyses of relative clauses and clefs and causative constructions, and phrase structure rules associated with certain categories. So phrase structure rules for verb phrase versus noun phrase and so on. Now, there was good news in this. What developed were tools for identifying phrases, a powerful means of representing phrases, this crucial property of recursion, and phrase structure grammars for various languages emerged with rich, deep descriptions. Many new phrasal types in a wide variety of languages were revealed. But there was also a certain amount of quote unquote bad news. And what this really is the quest for explanation. So why questions were answered. One issue, for example, was it wasn't clear how these phrase structure rules could be learned. They didn't meet the condition of learnability that we talked about earlier. There's an infinite number of possible phrase structure rules for any given language. So how did the child converge on the right set for the language that they happen to be learning and do so in so short a period of time? Anything could be rewritten as anything. So how did the child converge on the right system? And there were no answers to key why questions like this. What was found was that in a phrase like a verb phrase, you could have material before and after the verb, but it always had a verb in it. It was endocentric. And that was true for the other categories as well. And then the question arose, why these rules and not others? Why did a verb have the label verb phrase above it? And that was true by pure stipulation. I could have written a rule that says verb phrase consists of adjective, but I didn't find that. I only found this. So for these reasons and for others, continued investigation occurred, and we reached the next stage in the development of phrase structure within the generative enterprise, which is called the X-bar template. And I want to say a word or two about it. Phrase structure rules had rich descriptive adequacy, and they solved the problem of discrete infinity. But ultimately, the phrase structure rules turned out to be non-explanatory. They were unconstrained. They were too stipulated. So the next stage in the development, this X-bar template, was the attempt to impose tight restrictions on what counts as humanly possible phrase structure representation. What was found is that in certain phrases, so a noun phrase, I found inside it a certain structure, and I'll represent that structure with just a triangle. But it turned out that there was cross-phrasal uniformity. When I looked at another phrase in the same language like verb phrase, at the right level of abstraction, I found that same basic structure. And that was true with the other phrases, adjective phrases and prepositional phrases at the right level of abstraction. They had that same basic structure, and that was true across languages as well. So the idea was to distill out, to factor out that abstract structure removed from any particular phrase and have a general notion of phrase, abstract phrase. And the idea was that it was endocentric. It had a head, and then it had material that was semantically closely associated with that head, and then it had material that had a more peripheral association with the head. So that was this basic template for all phrases. Now, this did a number of things. One thing, it led to massive simplification of the earlier theory. So earlier we had language-specific phrase structure rules, the phrase structure rules of French, construction-specific and category-specific phrase structure rules, all sorts of them. And those were all reduced down. They were eliminated in favor of just a few simple rules that gave us this X-bar template, this abstract notion. So there was massive simplification. Another kind of simplification you had was the removal of linear order. Linear order was pushed out into the sensory motor interface where it seemed to belong. So consider something like this. That's a verb phrase, and it has a verb and an object. Now, if I remove linear order, those two things are spinning. Now, notice the structure stays the same. It still consists of two things, a verb plus an object. So I can have the same structure, but different linear order. So the idea was that basic structure was true for human, and then I linearized it for particular languages. So what you're born with is that basic structure, and that's still spinning like a spinning mobile as it goes into the semantics. The semantics doesn't care about linear order. It just wants to know that these two things go together semantically. But when I give it over to the sensory motor system, at least with spoken language, that's two-dimensional. So I have to linearize it. One thing is pronounced before another. So that linear order was removed. And that gave me a way of thinking about this question of how can there be one language in multiple languages? What you're born with is that spinning mobile, the abstract structure that's by hypothesis true for all languages. But then you can linearize it in various ways. When I combine a subject, the subject and the verb phrase are also spinning. So the subject could come before and after the verb phrase, but I would still have the same abstract structure. And that would give me different word orders. I could have object, verb, subject languages or subject, verb, object languages and so on. So I have an abstract notion of language, that spinning mobile structure. And then I have particular settings of language, what are sometimes referred to as parameters, different word orders. And that gives me a notion of same and different. So the overall view would be, I want to characterize the initial state. The initial state is going to include this universal grammar. That is the initial state of the cognitive capacity. And it's argued to have this X-bar template in it. That's what you're born with, that you have, that the puppy doesn't have. And this is called the first factor that plays a role in language acquisition, the first factor. And now you interact with the environment and I get states attained. So I get input that allows me to linearize, and then I can wind up with particular languages. And we'll see more about this notion of factors in just a minute. Okay, so we have a partial answer to how is this possible. All right, so here's where we are in the big picture. We're focused on this area right now, this computational system. And there are two computational devices I want to touch on. Phrase structure, well, we just talked about it a little bit and saw a lot of simplification of it over time. And I want to spend a few minutes on displacement, and then we'll close up. All right. We mentioned earlier this curious phenomenon of displacement. So consider the sentence, which man do you think that John wants to visit? The interrogative expression, which man, is pronounced at the front of the sentence. But it means down here, it's understood as the direct object, and given the system that we've put in place, it must have started life down there because it had to have been inside the verb phrase. The verb visit and which man go together to create a semantic unit. So the semantics has to have which man there. But there must be a mechanism then. So there must be a mechanism then that takes which man and basically moves it to the front of the sentence. You can think of it metaphorically as moving it up here. So it winds up being in two positions at once. And that's displacement. Now, it's interesting because relative to this position, that's where the sensory motor system is going to pronounce it. But relative to this position, that's where the semantics is going to interpret it. So it's in two positions at once. And there are a few things I want to say about this basic notion of displacement. One, it's pervasive in the languages of the world. We see it everywhere and in many different ways. This is just one more obvious way. And the other, I want to note the oddity of displacement. Why would language have such a thing? In fact, it causes trouble for the human sentence parsing mechanism for systems of use. You've got to get that interrogative expression, which man, at the beginning of the sentence, hold on to it in memory while you're building up the structure in order to finally figure out where it's going to be interpreted. So we have the question, why would such a thing exist? But here's what we have. This idea is you've got a phrase structure component and you need a separate component, a separate component called the transformational component to deal with this notion of displacement. Phrase structure was not sufficient. So the rough idea is the phrase structure component built structure like we saw before. And then the phrase structure component did a bunch of things. I want to focus on just one sub-mechanism, and that's movement, what's metaphorically called movement. So the transformational component would take a structure built by phrase structure and then manipulate it. So it could, for example, move something from one position to another like that. That's structure manipulation, but it was considered that there were these two separate components. Again, the transformational component developed parallel with the phrase structure component, and we found rich descriptive analyses of a wide variety of languages. So there were transformational rules for particular languages, the transformations of French and Zulu and so on, and transformations for particular constructions. So the transformations needed to account for certain properties of relative clauses and clefs and so on. So important discoveries were made as these transformations were developed. Many facts about a wide variety of languages were revealed for the first time. So again, there was good news. But again, key questions arose. Why questions? Why these transformations and not others? There was a issue again with learnability. How did the child converge on this particular set or the particular set of rules that you found in French versus English? And what happened over time, over a pretty long period of time, was that various properties of the transformations were factored out. So what do the different transformations have in common? What sub-mechanisms do we see over and over again? And one of them was this idea of movement. So what was factored out of those language and construction specific transformations were general notions of just move something. And eventually you got down to a single simple notion of a transformation, this sub-mechanism of just movement. Take something and move it from one position to another. And what arose are general principles. The other work that the specific transformations did was taken over by general principles that were also distilled out. And these general principles were considered to be part of first factor, that is part of your innate endowment, part of universal grammar. So this led to an interesting conception of language, which is basically it's a constellation of settings of particular parameters, linear order, and certain ways that movement could work. And so I could maintain the overall empirical power with a much simpler system. So overall, what we see happening through the 60s and the 70s and into the 80s is the reduction of phrase structure from language specific and construction specific to very general and abstract that applied to all languages. And then transformational components reduced down to a single simple operation that's not language or construction specific, move, and then this rise of general principles. So here's the overall system. And what happened was this computational system here in the early days of the generative enterprise was very complex. We had a wide variety of phrase structure rules and a wide variety of transformations that were language and construction specific. And those were eventually reduced down to these very general structure building and movement transformations. And then that was sort of surrounded by these linguistic principles, these general linguistic principles, not specific to any particular language, but specific to universal grammar, to the human language faculty. And so we could maintain descriptive adequacy. Okay, so how do we characterize how can there be one and multiple languages problems, the one and multiple languages problem now on this system? Well, UG has got a number of elements in it. So we characterize the initial state and we say what you have that the puppy doesn't is that basic template, basic operation of move, and these general principles. And then you get experience, you interact with the environment, and that's going to give me a constellation of parameter settings that's going to yield a certain language, what we call, sort of epiphenomenally call, a particular language. Okay, so we're looking at the generative enterprise. We've looked at two central properties of language, phrase structure and displacement. We've looked a little bit at the simplification that happens, and I want to conclude now with this minimalist program and the relationship between minimalism and explanation by simplification. So it's these two parts that I want to spend the final minute or so with. Okay, the minimalist program. A number of things are meant by this label. On the one hand, the minimalist program is just the name given for the continued development of the theory. There's a direct line from the earliest work in the generative enterprise to and through the minimalist program. On the other hand, minimalism refers to a method. It's basically Occam's razor. Deduce as much as possible from the fewest simple axioms. And this is something we've really already seen. Phrase structure rules and transformations were reduced to a simpler form. And many of the properties of those older style phrase structure and transformational rules were derived from independently motivated principles of the grammar. But this methodology takes on greater significance during this minimalist period. Chomsky states it in the following way. Throughout the modern history of generative grammar, the problem of determining the character of the faculty of language has been approached from top down. How much must be attributed to universal grammar, this initial state, to account for language acquisition? The minimalist program seeks to approach the problem from bottom up. How little can be attributed to universal grammar while still accounting for the variety of I languages attained, relying on third factor. And we'll see what third factor is in just a second. Applied to the computational system, the basic idea is what's the least that we can say? What do I have to have in order to explain language? What's the least that I can say? What's required by conceptual necessity? And I want to say as little as possible beyond that. Well, one major development in the minimalist program is that it reconceptualizes and reconceives structure building in such a way that the transformational component is reduced to the phrase structure component. It's reduced down to a simple single operation called merge. And this is based on important work by Hisa Kitahara in the 1990s that I think is only recently being fully recognized and fully appreciated. So we're reconceptualizing structure building, and it allows us to collapse phrase structure and movement into just one operation. And here's the basic idea. What's the least that we can say? Well, there is structure. A core property of language is infinite use of finite means. So the least that we can do is take lexical items and build something out of them. And the least that I can say is to have any kind of relation, you take two things and you build a new thing out of them. That's what it is to build something. So oversimplifying somewhat, let's take a look. Suppose I reach into the lexicon and I draw out the and woman and put them together. So that's kind of floating in that computational space. And now I'm going to take visits and Colombo out of the lexicon and put them, and they're sort of floating in that computational workspace. Now, the basic reconceptualization of merge says, structure building says, take two things. There's one and there's another. And I'm going to put those into a bigger things. I'm going to build something out of them. Take those two things and put them into a new thing, put them into a set. Now, I'm going to do the same thing over here. I'm going to take two things. There's one and there's another. One of them is contained inside the other, but that's fine. I've got two objects. I'm going to keep them completely intact. I can't alter what I'm going to merge. I'm going to take two things and put them into a set. So here's what I'm going to do. Exactly what I just did. I'm going to take those two things and put them into a set, put them into a larger thing, build something out of them. I'm going to take those two things and do exactly what I just did with the woman visits Colombo, and I get displacement for free. Displacement automatically follows from that conception of structure building. In fact, you would need a stipulation to not have displacement, one thing in two positions at once. So we have an answer to the question, why would language have such a thing? Because it has structures at all. And then the sensory motor system is going to pronounce one or the other, given certain efficiency considerations. Chomsky has an interesting, oh, by the way, so this is going to lead to really massive simplification. We looked at the simplification of phrase structure down to X bar, transformations down to move, and now we're going to take this final step that both of those are reduced to merge, and the history of the generative enterprise is in large part that massive simplification. Chomsky states it in the following way.
In the 60s and on, there were efforts to whittle away at the complexity of transformational grammar, and they reached considerable success by, say, the 1980s. So you had two systems, but simpler ones. The next question was, can we reduce them to the same operation? Well, that turns out to be possible, in fact, necessary, namely merge. They're reduced to the same operation. Okay, now you've reached the limit, aside from things you don't understand, which is enormous. You've reached the limit of what can be done to reduce universal grammar to its absolute minimum.
So reduction to the minimum, what we see is the computational system. This is what we've been focused on. We've seen phrase structure and displacement. We've seen those go from somewhat ad hoc and unconstrained and language and construction specific operations to those templates, X bar, and basic idea of merge. And those are finally reduced down to just merge itself. Okay, so what I want to do now is talk about what's called third factor. We've talked about this idea of what factors play a role in going from your initial state to the steady states. What's called first factor, that's universal grammar, the initial state. That plays a key role, obviously, differentiating you from the puppy. The second factor is considered experience. And the third factor now is principles that are not unique to language. So what's evolved, what's emerged over the last couple of years is the idea that we want the computational system to be subject to basic laws of nature. that will allow for even further reduction of universal grammar. So there are various subtypes of these. The one I just want to mention is has to do with efficient computation. There are certain laws of computational systems and organic computational systems in particular that have the idea, have the flavor of least effort and reducing resources and less choice. And those in large part replace the language specific principles that we saw earlier. And so what's the least that we can say? Well, the most basic picture that's evolved over the last few years, that's emerged over the last few years, is the least that we can say is you got to have linguistic features of sound and meaning. Those are the axioms. Those are irreducible. You build lexical items out of those. You give those to the simple computational system merge. It's going to construct objects, including displacement, and give those to the interfaces for sound and meaning. And then the whole thing is subject to these third factors, laws in general of computational systems, not just the linguistic system. And with the interaction of these things, we're able to maintain the kind of empirical coverage that we had earlier. And that leads to my very final point, and that has to do with explanation. When have we explained something? That's a very difficult question. But one mode of explanation involves simplicity. What we find through the history of the development of the generative enterprise is the reduction of the inventory of theoretical postulates within this narrow I language. What was syntax internal and syntax specific and construction or language specific in earlier stages of the framework was reduced or factored down or eliminated. The effects of these postulates were in large part derived from the interaction of that narrow computational system with the systems that it necessarily interfaces with, sensory, motor, and conceptual intentional, and with the laws of nature. Regarding the role of simplicity in science, John Forbes Nash writes, resolve to maximize our understanding, we find ourselves committed to a highly characteristic effort to minimize the number of theoretical premises required for explanation. Einstein once wrote, the grand aim of all science is to cover the greatest possible number of empirical facts by logical deduction from the smallest possible number of hypotheses or axioms. And Chomsky has often stated, it's long been clear that the quest for simplicity is closely related to the quest for explanation. With the reduction of UG to merge, I have the reduction of what's language specific, and the more prominent role that's played by these language independent systems and mechanisms, third factor. And to give a short sort of time-lapse photography of the history of the generative enterprise, what we see is the reduction of UG. Initially, UG included everything. It was huge. The lexicon was in there, all operations, mechanisms were in there, whatever worked to get descriptive adequacy. But as we've seen through the history of the generative enterprise, UG was steadily reduced. What was considered to be part of the uniquely human language faculty got progressively smaller. Less and less was in there, down ideally to just recursive merge. That's what you have that the puppy doesn't. And again, we see the role of these independent systems, the interfaces of sound and meaning are going to shape in part the way that that merge operates and the critical role played by third factor, these laws of nature. The reduction of UG to merge is simplification, and simplification is good standard science. It also meets the condition of learnability. How can the language be acquired? That is the core I language that we're talking about. And the answer is, it isn't learned, it's innate. The heart of it, that computational system, the heart of I languages, we're conceiving of language, isn't learned, it's innate. And in very recent work, it's said to meet the condition of evolvability. The less that's unique to humans relative to the language faculty, then potentially at least, the better the position we're in to account for the recent emergence of the language capacity in humans. And that's recent work by Berwick and Chomsky. So there's a little bit on the generative enterprise. I hope to have captured some of the progress of it, and for me, at least, some of the excitement of it and excitement for the future. We see steps toward our shared common goal of understanding language. So thank you very much. Again, I really appreciate being here, and I'm happy to take any questions you might have. Thank you.
Thank you very much, Professor Seeley, and especially thank